Hello everyone. This is the first video of the topic chromatography. This is a chapter from analytical chemistry paper 4 and unit 3. Now, what are the learning outcomes of this video? After seeing this video, you'll be able to define what is meant by chromatography. You'll be able to identify the phases involved in the separation of chromatography. One would be able to classify chromatographic methods based on stationary phase, mobile phase, and the physical factor responsible for separation. You will also be able to understand the role of adsorption, partition, and ion exchange in the separation of structurally similar components of a mixture. Also, you'll be able to see the different applications chromatography offers in various fields. Let us first try to understand the history of chromatography. The first chromatograph was invented by a Russian botanist, Mikhail Svet, in the year 1903. What he was doing is he was trying to separate plant pigments, which are chemically very similar to each other, and in an attempt to separate, he had a setup of this chromatography, and the setup was something like this. The setup has been shown over here. So he had a column which was filled with calcium carbonate, and he was using petroleum ether as a mobile phase. This is a plant extract. So he had tried many times to separate these components, but was not able to get a proper separation. So one day he was fed up, and what he did was he took the column, he added the plant extract, and he poured sufficient quantity of the mobile phase and left it to run overnight. Next day when he came and saw the column was looking something like this, as if someone has painted the column with these colors. So each pigment stuck to the powder with a different degree of strength, creating a series of color bands. So all pigments that are there in the plant, they were separated very nicely from each other, and it was looking like someone has written with color. So that is how the name got discovered. So chroma means color and graphos means to draw or to write. So he achieved separation of plant pigments. So basically it is a separation technique. What did he use? He used petroleum ether as a mobile phase, and he used calcium carbonate as a stationary phase. So we need to understand here that in order to separate, we require two phases, one which will behave as a stationary phase and the other one which will be acting as a mobile phase. So chromatography is a technique by which a mixture sample is separated into components, and two phases are necessary, as we just saw. Why this particular technique was important is that you can see there are around 12 Nobel Prizes which were awarded between. Now, why we need to separate? What is the need for separation? You can see this picture, and I think most of you are familiar with this plant. It's a periwinkle plant, vinca, which has n number of alkaloids, and most of its alkaloids are having medicinal properties. Now when you want to extract any alkaloid from a plant, a particular alkaloid, you need to separate other alkaloids. So whether it is an organic or inorganic compound obtained by synthesis or from natural sources, generally it is in the form of mixture. And it is extremely important to purify or to separate them into pure compounds if we really want to make use of that particular compound. So in vinca, I have just listed one of the alkaloid, that is vindicin, which has anti-cancer property, and it is used for the treatment of cancer. There is one more example over here of chloroquine. You must be knowing this. It is discovered from a bark of cinchona. So cinchona bark may have n number of components, but the one that is useful is chloroquine. So chloroquine can be separated from rest of the components by using chromatography. So in short, we can say that what is the role of chromatography? It is used to know the number of compounds or components in a sample. It can also be used to identify the compounds. So basically chromatography is not only for separation, it is used for three things: separation, isolation, and even for identification. To know the relative quantities of the compound, one can find out by comparing with standard how much is a concentration of a particular constituent in a sample. It can also give you a quantitative separation. As I said, it can be used for isolation also. What are the basic chromatographic techniques? So there are n number of chromatographic techniques, but for your level you need to at least know some of these that are mentioned over here: thin layer chromatography, paper chromatography, column chromatography, gas chromatography, ion exchange chromatography, and high performance liquid chromatography. Now, in order to remember so many different types of chromatographic methods, it's always better to classify them in a simple manner so that we can understand, or we can rather remember which chromatographic method falls under which category. So for that you need to see the next video or next set, that is classification of chromatographic methods. Now let us see the next part of the video, that is classification of chromatographic methods. Now there are different ways in which one can classify these chromatographic methods. First one is based on the stationary phase that is used. Number 2 based on the mobile phase that is used. And number 3 based on the physical factor that is responsible for separation. As you can see here, that classification based on stationary phase, we already know that in order to do any chromatographic analysis, you need to have two phases, stationary phase and a mobile phase. Now you have two choices of stationary phase. You can use solid as a stationary phase, or you can use liquid as a stationary phase. Now whenever you're using solid as a stationary phase, it can also be called as adsorption chromatography, and when you're using liquid as a stationary phase, it can be called as a partition chromatography. This is nothing but the actual factor that is responsible for separation. Separation happens due to partition in this, and separation happens due to adsorption in this. Once you have chosen solid as a stationary phase, you have two choices for the mobile phase: gas mobile phase or using liquid as a mobile phase. Now some of the techniques in which the gas is used as a mobile phase and solid is used as a stationary phase is gas solid chromatography. And the techniques where liquid is used as a mobile phase and solid forms the stationary phase, for example, column chromatography, thin layer chromatography, and ion exchange chromatography. When you are having liquid as a stationary phase, you can again have two choices: using gas as a mobile phase and using liquid as a mobile phase. When you use gas as a mobile phase, then that technique is called as gas liquid chromatography. When you're using liquid as a mobile phase, that technique is called as the technique which usually has these combination is paper chromatography and high performance liquid chromatography. This is a second way of classifying based on the mobile phase that is used. So based on the mobile phase, as we all know, the solid cannot be used as a mobile phase, so you are left with two choices: using liquid as a mobile phase or gas as a mobile phase. Once you have chosen liquid as a mobile phase, you have choices of the stationary phase. So if you actually see, this is in short a reverse of what we have seen in the first classification. So if your liquid mobile phase is a liquid, then your stationary phase can be solid or it can be a liquid. So what categories of chromatographic methods fall under this combination is column chromatography, TLC, and HPTLC. And then the chromatographic methods where liquid is used as a mobile phase and stationary phase is also a liquid, you have HPLC and paper chromatography. Going to the next one, that is using gas as a mobile phase, you can have solid stationary phase or you can have liquid stationary phase. When you're using solid as a stationary phase, then the factor that is responsible for separation is adsorption. When you're using liquid as a stationary phase, and the factor that is responsible for separation is partition. So which methods fall under this? Here you can write gas solid chromatography. Here you can write gas liquid chromatography. This is a third way of classifying chromatographic methods. It's a very simple one. It is based on the form of stationary phase that you're using, whether the stationary phase is in the form of a planar surface or it is in the form of a column. If the stationary phase is in the form of a plane surface, then this happens in paper chromatography, TLC and HPTLC. And where we use stationary phase in the form of a column, all the other techniques that are mentioned, that is GSC, GLC, column chromatography, HPLC and ion exchange chromatography.